Hello everyone, Mr. Suraj here, and today with me my colleague LK is here. He has graduated, he has completed his masters from IIT Madras, and currently he is in the industry working in the domain of analog VLSI and analog electronics. So let's discuss with him and understand the what exactly is this subject is and what are the key topics in that. Okay. Hello, hi LK, how are you?
Yeah, I'm fine. How about you?
Yeah, I'm also doing good. Like, can you tell more about your masters and then industry where you are working right now?
Yeah. So starting with my master's, so I graduated GATE and joined this analog design course, MS in IIT Madras under Professor Nagendra Krishna Puda. So
Mm-hmm.
in my master's, I worked on a hearing aid IC, which was a product which was given to CDAC company. So there I
Mm-hmm.
have designed OpAmps, pretty much everything other than the ADC part. On the analog
Okay.
side, it included
Okay.
closed loop PWL signal modeling and everything. And then I
Okay.
graduated and have joined a analog company.
Okay.
So
Okay.
my main field is mostly analog design and
Mm-hmm.
also circuit modeling and all.
Okay. Understood. Understood. Okay. So now, like coming to your masters, and you have worked in the analog design. So in the analog
Mm.
circuits, what are the key subjects are there? Can you
Okay.
explain more about that?
Yeah. So analog electronics has been quite a matured field, but to understand analog first, we need some preliminary courses like
Mm-hmm.
electrical networks. That is the main course I will recommend for all subjects, though. Electrical
Mm-hmm.
networks. So it's the basic foundation for the electrical and electronics engineering. And then we have control systems, and
Mm-hmm.
then we have signals and systems.
Okay. Okay.
Hmm.
So
These
basically,
three things.
these three
Yeah.
things like network, signals, and the control are the basic building blocks for the analog electronics, right?
Yes.
Okay. Now, what are the key topics in the analog circuits? Like, let's say, from the basic topics from which
Mm.
student can start their learning.
Yeah. So if so there are two fields. One is like semiconductor devices and other are analog circuits. Okay. Both are analog
Okay.
only, but then
Okay.
basically we make circuits like op-amps using some transistors. So how to
Mhm.
improve the quality of transistors, which process, how transistors are made. So that is the portion which is more into physics and semiconductor devices. So
Okay.
that is also a course which is known as a semiconductor devices and physics,
Mm-hmm.
which deals on
Okay.
how to improve a single element. And then
Mhm.
analog circuit design is mostly using those elements and creating some practical circuits for some real world applications like a radio,
Mhm.
cell phone,
Mhm.
TV,
Okay.
wireless transceiver, receiver, something like that. So, yeah,
Mhm.
that is pretty much
Okay.
about it. Yeah. So
Okay.
if a
Okay.
student wants to start analog
Uh-huh.
circuits, he should
Uh-huh.
have some if not at a depth, but it should have some basics of semiconductors, like what are
Mm-hmm.
transistors, what are diffusion current, drift currents, this and that. Some
Okay.
basic level courses will be there in second semester, I believe. And
Okay.
once you brush that up, then you
Mm-hmm.
know what things are, and then we will jump into analog design. Yeah.
Okay. Okay. Understood. Understood. Okay.
Mm.
Yeah,
Yeah.
so you was talking about this semiconductor physics and the semiconductor
Mm.
devices. So can you
Mm.
give some brief idea about this subject and what are the key topics to the students?
Yeah, sure. So, so far we only deal about passive elements, right? Like we mostly make circuits with inductors, resistors, and capacitors. So these are linear circuits. So
Mm-hmm.
then there is a class of circuits which are known as nonlinear elements, and circuits
Mm-hmm.
associated with them are known as nonlinear circuits.
Okay.
So in nonlinear circuits comes diodes, BJTs, transistors, MOSFETs. Okay.
Mm-hmm.
So to understand the physics of how this diode works, we have to first understand the semiconductor physics, which
Uh-huh.
includes that PN junctions. So a
Mm-hmm.
diode is a PN junction. It is a two-terminal device. It has nonlinear IV characteristics. It will
Mm-hmm.
have some, so it has three regions of operation. and we have to go into the details of that. So
Okay.
how at a molecular level, a semiconductor is different than a
Mm-hmm.
metal and an insulator. What is the threshold
Okay.
energy,
Okay.
band gap energy, and all. Once that
Mm-hmm.
a student understands, then we should know how an ideal diode looks like. So we can't always solve these big equations, right? Or else life will become very hard. Because
Correct.
if you look into a phone, it will have millions of diodes or transistors, right? We can't put a large
Correct.
signal model for everyone. So we have to
Correct.
simplify
Correct.
the model. So there are
Mhm.
lots of simplified model. Then we need to learn how to solve the equations and simplify the
Mhm.
circuit and find out. Then there's a notion
Okay.
of large signal and small signal. Once
Okay.
students understands that, then we slowly study the transistor at a model level, meaning a current source,
Okay.
voltage controlled current source, all these things. And
Mhm.
then
Mhm.
we come to a single stage transistor behavior. We studied terminal characteristics, like
Mhm.
what are the terminals. Usually a transistor has a three terminals. So what voltage where
Correct.
to apply, what is the current voltage relationship,
Mhm.
what are its different mode of operation, where it is
Okay.
used. Like for example, a MOSFET in
Mhm.
saturation is modeled as a current source. So for
Correct.
amplification, we prefer MOSFETs to be in saturation, or BJTs,
Mhm.
whatever. Whereas if it is in triode, it's also a type of region where it is
Mhm.
used for switches, and if it is
Mhm.
off, it's used as a closed open
Mhm.
switch, and if it's an triode, it's an open switch. Sorry, closed switch. So
Okay.
all these things, once that is covered, then two transistor, three transistor, and then we move on to achieving a bigger goal, like building an OpAmp. So OpAmp is also a
Okay.
device that is very always used day in day out in every
Mhm.
electronic circuits, and it has its own terminal characteristics. So
Correct.
but those are made by MOSFETs only, and how and
Correct.
why.
Correct.
So once we have this nonlinear circuits, we understand
Mhm.
how things operate and how to calculate. Now comes circuit design. Now we
Mhm.
know how to solve a circuit. Now the question is, how will you design a circuit? Let's say I have some application. It can be very
Mhm.
simple, like an amplifier. Some small
Mhm.
signal is coming and I want to amplify. So in that case,
Okay.
I have to create an op amp and draw some circuits and all. But now the question comes about the stability, right? Because is the
Correct.
system stable? By stability,
Mhm.
in brief, is if I give some input, I should get some finite output. Okay.
Yeah.
Like
Exactly.
it should not malfunction. So
Correct.
is there a chance of malfunctioning? If yes, how do I control it? How do I bring it back to stability? All these things are,
Mhm.
for that we use control systems to find out. That is why I mentioned that control system is one of the important subjects to cover, right? Because in control
Exactly.
systems we
Correct.
learn about Bode plot, Nyquist
Mhm.
stability criteria, and all, which are highly used in this type of analysis. Once that
Okay.
is covered, then we come to non-linearity, distortion, and all. And that
Uh-huh.
for that we need to analyze signals in a spectrum level, in frequency domain. We know
Okay.
that signals can be represented in time domain and frequency domain, right? But in
Correct.
we can't extract all the information from time domain. Like how
Correct.
much is the harmonic distortion? So harmonic distortion is, I want an ideal sine wave at the output. So ideal sine wave
Mhm.
in it will have only one frequency component. But if I
Correct.
have a sine wave with a distorted sine wave at the output,
Mhm.
my
Mhm.
distortion should be under some level. To measure that,
Exactly.
we have to use Fourier analysis, Fourier transforms, and all. So those are
Mhm.
parts of signals and systems.
Systems. Mhm.
So this is how all the subjects are connected together, and by different knowledge, we analyze the circuit, use our knowledge, and build real world
Mhm.
application. Once we understand this
Exactly.
part, yeah, once this is done, then we will move on. So MOSFET is just a basic building block used for amplifiers. So
Okay.
amplifier is kind of a linear circuits. There's another type of circuits known as switch capacitor circuits, which are used for
Uh-huh.
ADCs. So this is a
Correct.
domain of mixed signal where analog interacts with digital, because
Mhm.
today we have moved quite ahead in future, right? Meaning we have cell phones which are using 5G technology and looking forward to 6G, high bandwidth,
Correct.
high signal processing power. So we all know that things
Mhm.
are moving towards digital. We are already in a digital world. It's no surprise. So, but
Correct.
our real world signals are all analog, right? So the biggest
Yes.
application right now that everybody is trying to build and has been building for the last 50, 60 years is converting the
Mm,
analog signal to the digital signal for processing. And that is
correct.
basically an ADC. Okay.
Correct.
So now ADCs, so if you say that from 50 years people are doing it, so what are we trying to do? So
Mm,
with increase in data, we are trying to process more information, and to process
correct.
more information we need to have more bandwidth. So the ADCs have to
Correct.
work very fast because we don't want to wait, right? If your phone starts
Exactly.
buffering to load a video, you won't like it, right?
Mm,
If this video starts
correct.
buffering, you won't like it. So what do you
Exactly.
mean by speed? So we have to operate it at high frequencies. So
Correct.
what topologies we can use, how to improve, and all these
Mm-hmm.
things are involved. So these are pretty
Okay.
much in a nutshell what are the challenges involved in this field and what you need to study to get a hold of the situation.
Situation. Okay. Understood. Understood,
Mm.
LK. So basically, like starting from the basics till the point, like building the OpAmp and the analog to digital converters, basically. So in terms of analog VLSI, what book you recommend, and then what are the key topics, and
Yeah,
in terms of layouts and all this physical design, if you can put some light
mm.
on that, it will be good.
Yeah. So like first of all, these three, four subjects are very important to understand. So for electrical
Mm-hmm.
networks, once I will say there's a book for
Mm-hmm.
um, Sadiku.
Ah,
Author name
Sadiq.
is Sadiku. The name
Correct.
I have forgotten, but we can search for it. In control systems, we have um, I'm just
Ogata,
forgetting
I
those
guess.
names. Yeah,
Uh,
Ogata is a very good book,
Ogata.
and Kuo is
Ah,
there.
yes.
Kuo,
Uh-huh. Yes, yes.
Kuo is also there. In signal
Mm-hmm.
system, of course, the classic book is the Oppenheim.
Open
Okay.
hand. Yes, yes, yes.
Yeah, and then in
Okay.
semiconductors devices, there are a lot of books. So yeah, it's very common. So you can look into any one
Okay.
of those. Then for analog
Okay.
circuits, the most common books that people should study is
Uh-huh.
Razavi, Behzad Razavi. So there are two
Okay.
books, Analog Electronics and Analog IC Design. These are startings.
Correct.
And also
Correct.
there are advanced topics like PLL, phase
Mm-hmm.
locked loops. It's also a
Mm-hmm.
type of circuit. Okay,
Mm-hmm.
that's a specialization. RF circuits,
Okay.
radio frequency circuits. All those
Okay.
books, like Razavi books, are also there. So these
Okay.
books, I think student can look
Mm-hmm.
for
Look
if
for.
they are
Okay. So
interested
these
in
are.
this. Yeah.
Yeah, 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 exactly. So,
Mm.
thank you for the book recommendation. So now going ahead, what are the like tools you recommend in these subjects, basically?
Yeah. So from electrical networks and all basic spice
Mm-hmm.
P-Spice or LT Spice. LT Spice, it's free.
Mm-hmm.
So students should be familiar with LT Spice, understand how models are made and all.
Mm-hmm.
So these are small circuit simulators. Of course, the industries and in big colleges, what we use are cadence virtuoso. That's for
Okay.
that you need license. But
Yes.
it's a cheap alternative is LT Spice
Mm-hmm.
because the point is to understand circuits, not at a production level, but then
Mm-hmm.
for at a theory level to understand how things work, right, and how it is
Correct.
simulated.
Correct. Correct.
So for that, LT Spice is very good. And other
Okay.
than that, small MATLAB modeling. So MATLAB will be
Mm-hmm.
helpful, but again, MATLAB needs license. So you can go for Octave. So pretty
Okay.
much Octave and LT Spice a student should master to like you can then move on to other technology and other um, softwares very easily. Okay.
Okay. Okay. Understood. Understood. Okay.
Mm.
And then in terms of the projects, who are interested to do some projects in the analog VLSI and circuit. So, what kind of
Mm.
topics you recommend and which you have worked on?
Yeah. So usually in IIT Madras we had a coursework, and in that in analog circuits we first designed an OpAmp. But
Mm-hmm.
before that there were small circuits like common source amplifier. So all these were
Okay.
simulation based assignments. Other than solving questions, Of course, there will
Mm-hmm.
be some questions and all. We had assignments where we used to solve questions and all. Along with that, there were some simulator based assignments where we had to first design from, because it's when you start designing, you understand things well, pretty well, and you understand things better. So
Exactly.
you can start with a common source amplifier, then move to a common drain, common gate
Okay.
amplifier. Once that is done,
Okay.
you can shift to a differential pair, and then
Okay.
slowly to OpAmp. And then from OpAmp, you can design some logarithmic amplifier or something, or some
Mm-hmm.
mathematical tool, because OpAmps was basically used to do some calculation. That is why it's called operational amplifiers, right? So yeah.
Mm-hmm. Okay.
But
Okay.
yeah, then after that, in advanced courses, you can move ahead to build some bigger applications like a transceiver or a PLL.
Mm-hmm. Understood.
Those are
Understood.
advanced topics. Yeah.
Exactly, exactly. Yeah. So now let's take a one project. Let's say OpAmp, designing a OpAmp using a MOSFET. So what are the
Hmm.
key steps involved in doing this project? Like step one is
Hmm.
hand calculation. So step two is something. So can you please this procedure to
Yeah,
approach the
sure.
projects?
So let's say we want to design a simple two-stage Miller compensated op-amp. Okay, so
Uh-huh.
it's a type of op-amp where two-stage amplifier is there. So
Mm-hmm.
it's a very common project. For first, we have to decide on the topology. So basically, the question usually given to the students are like this: you will be given some supply, some technology, some gain.
Uh-huh.
So it's a spec sheet. So you will be given
Mm-hmm.
a spec sheet like your
Mm-hmm.
op-amp should have this, that. It should have
Mm-hmm.
this much distortion, this much noise, this much power dissipation, bandwidth,
Uh-huh.
gain,
Mm-hmm.
or supply and process node. All these things information will be given to you. Based on this,
Okay.
you can try to achieve. You can have to first come up with an architecture. Which architecture should you use? Like a NMOS differential pair or a PMOS differential pair with a PMOS
Mm-hmm.
load or an NMOS load in the second stage. That becomes crucial depending upon the signal swing. So all this you can calculate. Once you have done with an hand calculation, like
Mm-hmm.
some basic level, then you come to the circuit simulator, and then
Mm-hmm.
you have to instantiate your MOSFET at a particular node. By node meaning, those of you will know that a MOSFET will have some length, right? So that depends upon
Correct.
the technology. Like for example,
Correct.
TSMC has 65 nanometer technology where the MOSFET's
Mhm.
minimum length will be 65 nanometer, and
Correct,
you
correct.
can go for higher lengths, but you can't go
Mhm.
at lower lengths. Okay, so
Correct,
based
correct,
on that, your device characteristics you have to find out, and then
correct.
from the device characteristics you can calculate at what VGS you will get that GM, they get that operating
Mhm.
point, so that your small
Mhm.
signal parameters are fine. So you will
Mhm.
calculate and put width and length, so you have to do some DC operating point analysis, and
Mhm.
results should match closely if not exactly, because it also depends upon, because while doing hand
Mhm.
calculation, we take a square law model of the MOSFET. If you study MOSFET, you will come to know in BJT it's an
Mhm.
exponential model, and it's a MOSFET it's a square law model. But
Correct.
real life MOSFETs are quite complicated, and all are
Mhm.
it's not a square law model anymore. Okay, so
Exactly.
trying to say,
Exactly.
yeah, so
Mhm.
empirical models are there, like some parameter
Mhm.
fitting is there. So of
Mhm.
course there will be some drift, but your understanding should be like, is it hinting to what I am getting in my calculations? Like
Mhm.
if it is increasing with current, in simulations also it
Mhm.
should increase with current. Maybe not twice. Maybe in my calculation it is twice. In actual case it is
Mhm.
thrice. That is okay. But then
Okay.
the direction and fundamental analysis can be comprehended from hand calculation. And once that is
Okay.
done, once the OpAmp is done, you can have to do the stability analysis and reliability analysis. Once that is done, the project is completed. But it will take a lot of time for students.
Yes. Yes.
It's a 2 month project, to be honest. Yeah.
Correct, correct. Exactly, exactly. Thank you
Mm.
for the guidance on the stepwise procedures. Now we are at the end of our discussion. So, as you are
Mm.
already working in the industry in the analog VLSI domain, so what exactly you suggest to the master students who are trying to get into the industry?
Okay. So first of all, what I have seen is that in masters there's a lot of pressure, right? Because now you are
Mhm.
going into the advanced topics. So I will
Uh-huh.
recommend first, before jumping into big topics, clear out your
Uh-huh.
basics. Okay, you
Okay.
should understand fundamentals very well. Only then you
Mhm.
can debug or crack any complicated circuit, because complicated
Okay.
circuits are made up of the small elements only. Once
Mm-hmm.
that is done, then you should always do some project. You should be very hands-on. Okay. Like
Mm-hmm.
you should be very familiar with writing equations, doing small signal analysis. In a blink of an eye, you should be able to write that. And you should be very good at analysis also. So,
Okay.
and then and also you should, a student should always diversify. Like, don't
Mm-hmm.
stick to OpAmps only. Once you know the OpAmp, make something useful out of it. Because I have seen
Okay.
students doing a lot of projects, but is it
Mm-hmm.
applicable? Where will it be applied? Some
Mm-hmm.
small application you have to build. Like, let's say,
Okay.
yeah, like you, it can be anything. Like, for example, mm, let me take an example. Okay, like a temperature sensor. Okay, electronic
Mm-hmm.
temperature sensor. Those
Okay.
they are also, there will be some band gap and these things are applied. So whatever you know, band gap, who requires a band gap? But a temperature
Mm-hmm.
sensor, it will be required, right? For alarms or
Correct.
anything. Yeah. So you
Correct.
have to build some application using your
Mm-hmm.
knowledge. I think that will be the best for the master students.
Master students. Okay, understood.
Yeah.
And then, what kind of interview questions they ask for the analog industry?
Okay. So they will initially start with some RC circuits, because RC
Mm-hmm.
circuits still shows how the student understands the linear elements properly.
Mm-hmm.
And sometimes it becomes very difficult if you add switches and all. And then they will move on to OpAmps, and then noise, stability, some
Mm-hmm.
distortion, and
Mm-hmm.
design parameters. Only these things are mostly asked. And if it's a
Okay.
master students, then or a final like BTech or graduate, they
Mm.
are from final year project, they will mostly ask also.
Oh, okay,
Mhm.
okay, okay. Understood, understood. Okay, thank you very much, LK, for
Yeah.
the discussion and giving out your time. And have a nice day. Bye.
Yeah, you too. Thanks for the opportunity. Bye.
Yeah, thank you.